How to build a solid-state Tesla coil. All you need for this circuit is a IRF P450B MOSFET, potentiometer 10 kiloohms, 47 nanofarad 50 volt capacitor, a 1 kiloohm resistor, breadboard, optional unless you want to solder it to a motherboard, and a primary and secondary winding. Started, we'll learn the parts. A MOSFET is a high-frequency switching transistor with a diode inside of it, I believe. You have the gates on the far left, the drain in the middle, and the source on the right. The gate is what receives the signal that is inputted to the transistor to switch, the frequency. The drain is what gets connected to positive through the primary winding. The source gets connected to all negative rails. Now you just take your MOSFET, plug it into your breadboard, like so. Now take your 50 volt 47 microfarad capacitor with the tape here, with the gray tape facing left, place it inside of the breadboard. Like so. Take your 1K resistor, brown, black, red, gold, place it between the positive of the capacitor and somewhere on the breadboard. Like so. Make sure it's a snug fit. Now take your 10K potentiometer. This is what you need to understand. The potentiometer has 3 legs. The middle leg, the left leg, and the right leg. The left leg goes to minus on the capacitor, so that where the tape is. Where the tape is, the left leg gets connected to that. Like so. See how it's the left leg gets connected to the negative on the capacitor. The right leg, the far right leg, gets connected to the end of the resistor where we plugged into the random spot on the board. Now finally, for the variable resistor, we plug the middle pin into the source, no, into the gate, sorry, the gate of the transistor, right here. Goes right here. Hold on. See how I plugged it in? Right on the gate. Now you take your piece of hookup wire and plug it in to the drain, the source of the MOSFET. Like that. Now bring that wire all the way over to the minus on the capacitor. This one's not long enough. I have to use a longer one. Like so. This gray wire goes all the way to the negative of the capacitor, all the way over to the source of the transistor. Or MOSFET, sorry. Now that's the circuit. Now you gotta hook up wires to the Tesla coil and the input. Take one hookup wire, connect it to the rail of the positive of the capacitor and the negative. Like this. Like so. See how each side of the capacitor, one goes to the left and one goes to the right. Left and positive and negative. So now I just bring that wire over here, get it out of the way. Take another wire and hook it to the positive of the capacitor. So you have 2 wires coming out from the positive. Like so. See, it's on the same rail as the resistor going out. Alright, we're almost done here. Take another wire, put it into the drain on the MOSFET, the middle pin. Now finally have one more wire coming from the gate. Same pin as you connected to the middle pin of the variable resistor to. That's that long wire. You got this positive wire going this way, the gate, the drain wire, and the gate wire. So you have 3 output wires and 2 input wires. Now that the main circuit is done, we'll move on to the secondary and primary coil. The way a Tesla coil works is that you have a magnetic field that goes to the primary coil. It gets excited and makes a large magnetic field induced into the smaller, thinner wire coil called the secondary. It induces a magnetic field in there, and it exponentially gets more and more, I guess, intense as it gets to the top of the coil. And then outputting a high voltage output with a low voltage input. So when you make one of these coils, you need to wind it patiently around a tube. I use a cardboard tube with plastic caps. You can use pretty much any material other than metal. You wind it up all the way up. I've had some mistakes. You can actually have mistakes, I found. I had to rejoin some of the wire and resolder it, and it actually works pretty well. The primary coil is nothing special, just some household lamp cord that I found laying around. And you need to have a wire coming from the secondary on the bottom, not the top. The bottom, a thick wire. This gets connected to the driver circuit. We'll talk about this later. Alright, now we're going to hook up your driver circuit to the Tesla coil. Take the gate wire, tie that to the secondary, the bottom of the secondary winding. This part may get tricky because it sometimes gets pesky about which polarity you set the primary coil to. So what you're going to do is you're going to take this wire from the primary coil, the single winding, not the multi-winding. Take the single winding and tie this to the positive rail that we set up earlier. Like so. Positive to one side of the primary winding. Now take your other side of your primary winding and tie it to the wire that's coming from the gate, the drain. Now you should get ready to cross your fingers and power it up. To power the circuit, you're going to need a 12 to 19 volt power supply. I'm using an old laptop charger without a automatic switching fuse, so I can run it continuously without hitting a break. Very important step. You must need to know which wires you made negative and positive, because if you plug it in wrong, you can blow your MOSFET in one easy go. So you want to be very careful with it because there's no diode protection. You will take in my case, with this power supply, the wire that has no shielding is a negative, and the wire with shielding is positive. So you take the positive one and tie it to the wire coming out of where the resistor is, where the resistor goes down right there. So it would be this wire in my case. Now take your negative rail and tie it to your negative wire. And good idea to have a fluorescent bulb on handy to set it on top, because these Tesla coils don't produce that much power with low voltages, so you have to sense it by seeing the light turn on. Voila! The Tesla coil is producing output, getting the wireless energy going. This is your Tesla coil after you complete this simple, very basic circuit. Ow, that hurt. Warning, your MOSFET does get hot very quick.